Okay, right. Okay, let's start the class. Okay, basically, I'm trying out a new teaching tools where at my back here, you see the PowerPoint slides. Basically, it's just a green screen at my back. So, why I'm using the headphone and mic, a wire version, because this one, I tried the wireless version, but wireless version, the sounds quality is not uh, as good as the line-in headphone quality. So I choose this way. But I hope in future I can get a good wireless mic. Okay. Right. So if you have any good suggestion, then you can let me know if you have any. Okay. Um, Make sure you're in the correct class. All right. We are in the engineering dynamic class. Code is 2123, and make sure you already pass EMB2123 statics, engineering static class. So if you haven't get results for engineering static, please go to student record or go to your faculty or school, get your results. So make sure you pass, and then you're in the right class. We were going to use what you learned in statics, and then we will advance it into something dynamics. Okay, static means something doesn't move, but you need this understanding in what you learn in statics. We will try to relate the statics to something that's moving. That's why the word dynamic is there. So in this chapter, we will look at something that is moving, and then we study it, and then we come up with the equation to analyze it. Okay, right. Um, these are the explanation for this class. Don't worry, you'll get the PowerPoint later. All right. So in our class, if you don't understand anything that you see on the screen, you stop me and ask me question. Right? Don't let it pass until the next lecture or the next slides that I show you. Okay? Don't allow things that you have doubt to pass. So just stop me and ask, Dr. Ang, why this one? I don't understand. Can you explain it one more time? All right? So something like that. Now, I really highlight the important key for engineering dynamic class. So we will look at forces and torque. Okay, we'll look at forces and torque. Torque means forces that rotate. Forces that rotate. Forces can be one direction. They can be going a lot of direction. So we have forces and torque. Forces normally will be in a linear form. Okay, have a direction and magnitude. Torque, something that rotate. Okay, all right. So we will relate force and torque in this dynamic. And what happens if they are moving? So you can see here, I highlight the effect of motion, meaning you combine forces and torque, and then look at what happens if you combine these two on that body, then you explain. Explain through mathematical model, and we'll look at kinematics behavior. I will explain more on the word later when it comes to kinematics chapter. All right. Okay. Okay, so I need to check whether this one is correct or not, because okay, I think I need to change this one. I think not static. I need to check later whether either this one or this one, right? So as you can see here, you need to pass the theory of machine 2173. Okay, so all of you already passed this module, right? Correct? You have taken this.
Yes, sir.
Okay, let me know if you haven't passed this module. Theory of machine also talk about something that's static and moving a little bit, especially the gear, the rotation of the screw, and riveting and all this. So make sure you have the notes for theory of machine and even the statics. Okay. All right. Now the next one we're going to talk about is the learning outcome. Why all these are important? Because your coming test exam, we're going to come up question based on learning outcome, all right, or area that we're going to test you, area that we're going to assess you. So the first thing we're going to assess you or ask you question will relate to dynamics.
Excuse me, sir.
Yes.
Sorry to disturb. Sir, actually, some of us in the chat even touched the subject, the EMB2123.
Oh, so you haven't this one, huh?
Yeah.
Okay, so never mind. I will check later, but I think these slides will be the correct one. Okay. Okay, let me pull out the document I have. You can stop me anytime if you don't understand or you have doubt, right? So in my class, you are always welcome to ask question. In fact, I'll be happy if you ask question. Huh? Okay. I will check with the school. Basically, the document mentioned this subject, and the description document say that there is a subject there. But anyway, I think this one is more important. Make sure you already passed static. Okay, make sure you already passed static. Yeah. This one, give me some time to check with the office. All right. All right. I think, yeah, because if you look at the code itself, it should be at the same semester or next semester you're taking this one, right?
Excuse me, sir.
Yeah, go ahead.
Yes, sir. I think because it says this subject is a prerequisite
Oh,
for
yeah.
this.
For
So
this
good,
one, yeah.
this
Means
is for the
after
next
this, you
one.
learn this one, yeah. Okay.
Yeah.
Means you learn this one and then you go into this
Yeah.
one. Right.
I
Okay.
feel that's the thing.
Yeah. So, okay, yeah. Makes sense. Yeah, makes sense. Because when you learn about dynamics, force and torque and things that move, then you apply the equation for the machine. Yeah, correct. Makes sense. Yeah, good. All right, now back to the learning outcome. Again, why we need to stress on the learning outcome. This will be the area we ask question. So the first question when it comes to final exam, right, or test, will be more on dynamics. Especially when it comes to final exam, normally one question here, one question here, one question here, and maybe another one, right? So these are the key area that we're going to assess you. So the first one will be testing you more on the dynamics problems, means forces or torque that or things that moving, right? So this is the first thing. And number two is more on the unknown uncertainty. So when it comes to degree level, we will you always see unknown or parameter, for example, A, B, C, and so on. So you need to find out what is the parameter, what is the unknown parameter uncertainties in the question. Okay, so you use a concept that you learn in the class, and then you look at the problems. There will be something missing in the equation. Okay, there will be something missing in the equation. I'll give you an example. F equal to ma, second Newton law. F equal to ma. So in test, you'll be given the force, you're given the mass. You need to find the acceleration. However, the question will not directly give you the acceleration number. You need to find the acceleration from the description in the question. So something like that. Okay, and then this quantitative model means you need to use the correct equation. to define the problem. Okay, quantitative means something that you can calculate, and another opposite of the word of quantitative will be qualitative. So quantitative model is important for dynamics, engineering dynamic class. Just be careful when you write your answer for your test or even your assignment or final exam. Make sure you use the correct unit, because you deal with the force and torque, and then you will come up with another new entity or new effect. So when you have the effect of motion there, you have a new unit. All right. Now force, if you derive the force equal to ma. So force can be put in Newton. It can put in kilogram meter square divided by s square. Because if you take the m times the velocity, right? Not m times the acceleration, you'll get m times the ms divided by s, right? Acceleration unit, right? So something like that, right? So I will use the pen later on, right? So, but never mind. As long as you understand what is a quantitative model over here, and then also one of the things that we will assess you is you're able to do approximate an assumption, okay, in the problems. So solve and validate with approximate method or assumption. So when we talk about equation in engineering dynamics problems, there will be assumptions. So for example, you need to use F equal to ma. What are the assumptions before you use it? So you have to know the assumption before you use the equation. Or if you want to use the equation, what is the limitation of this equation? So for example, if you learn about fluid mechanics, then you will come about Bernoulli equation, so, and all this. So what are the limitation or assumption that you need to take care of? So these are the area that we are looking for. This is my general information. So this is my full name. You can address me as Dr. Ang. All right. And if you want to know more about me, just type in my full name in the Google. You're able to see some of my information online. All right. And this is my temporary email that I use. This is my personal email. I will let you know the official email in the coming class. And my contact number I don't put here is because this video will broadcast to YouTube, and everyone in the world will see my information. So in coming class, maybe I will add in or maybe not, but most of you in the class, you already have my number in the WhatsApp group. So you can, if you have any question, you want to see me, text me and then make appointment. Or you can text me and then ask, Dr. Ang, do you free or available when and what time? All right, can I see you? All right, so this period we will have online, but if you happen to be in campus, you are welcome to see me. But make appointments first, because I might be busy with other module, or I might in the lab, I might in the workshop, or I might be somewhere else. So I don't want to disappoint you. You so excited come to campus, but you found that your lecturer is not in the campus or not free to meet you, right? So I don't want to disappoint you. So this is the on paper my consultation hour, but please, it will be good if you text me first before you come and see me, just to check where I am. Okay, all right, and it would be good if you don't text me on Saturday and Sunday. I mean, don't text me on weekend and also public holiday. So but anyway, you have an urgent matter, you can still text me. All right. However, if your message come in on Saturday and Sunday, I will read it. You'll see the two tick behind the WhatsApp message, but I will reply on the next office hour. Most probably, if you send on Saturday, you won't see reply on Saturday, but you see my reply on Monday. Okay, unless it's very urgent, then I will reply. Okay, and also when you want to come to Singapore, you happen you see me in campus when I was having my breakfast, when I'm having my lunch, or having my dinner in the cafeteria. You are welcome to drop by to say hi to me. However, if you want to ask me question about module or something deal with your studies, it will be good if you make appointment first. Don't give me surprise when I'm eating my bihun or drinking coffee. Suddenly you ask me question on your module and so on. So I need to have some time to prepare for it. And when I'm eating something, actually I'm processing some of the information for the task given to me. So yeah, so I might get distracted on that. So yeah, so that is my way of communicating for class and also for this module. Any questions so far?
Yes, sir. Sorry,
Yes.
sir.
Yeah.
On our class on Friday, right, sir?
Yeah.
I actually have a subject clashing at the same time.
Oh, okay.
Is it possible to reschedule our class?
Um,
Because
you
it's
clash
taking up
with what? You clash with what module?
the elements of electrical engineering.
Okay. Anyone in the class also taking the same module?
I'm not sure. I don't
Yeah.
think so. Anyone else is.
So yeah. Anyone in the class, if you're listening, are you also taking the electrical module?
No, sir.
Okay. So only
sir.
who? Sorry, I can't see your name or at my screen here.
Sivendra, sir.
Oh, Sivendra. Okay. Yeah. What I can give what I can suggest to you at in our class here is that maybe you should talk to Rohit, head of department. You have Rohit contact?
Yeah, I have spoken to Mr. Rohit.
Yeah.
Already.
So what does he say?
Unfortunately, he said just like ask the lecturers instead because they will have the better idea of how we can manage
Oh,
reschedule.
okay. Okay. Yeah. All right. So okay. Just for info, my schedule for this semester, I have 6 module to handle. I have,
Okay.
yeah. So just for info, so I will have available time on for dynamics. I will have available time. I'll just give you my available time, so you see if you're able to make it. All right. So yeah. Okay. Let's settle the schedule. So I will available on 10:30 or Tuesday. Yeah, Tuesday 10:30 to 12, around that one, or Tuesday after 3:30.
Okay, Tuesday after 3:30 is fine with me, sir.
Yeah, but you have to check with other 6 of your classmates.
Yeah. I mean, if all
So
is okay.
yeah, so any one of you have class on Tuesday after 3:30. Can you help us to check your schedule now? But anyway, okay, let's look at the schedule later, right? Because this is a recorded video, and
Okay, sir.
yeah, so we will discuss that later, right? So we clear our introduction first, then we come back to your schedule, right? Sorry for all the watching on YouTube. You can fast forward if you want to hear more information about the module. All right. Okay, so this is how we access the class. So you have 50% coursework, 50% final. So you have 2 tests. One test is about 15%. So 2 tests, test 1, test 2, and then you'll be given 1 individual assignment to submit. So 30 plus 20, you get 50%. However, all the paper will mark in either full mark of 50% or 100%. Then we will convert into 30% as a, for example, for test component will be 30%. For assignment, total marks for assignment, when you pass up, I will mark in 100, I will convert in 20%. Then I will add all together. Just a reminder, you need 80% attendance to sit for final exam, right? But I believe all of you won't miss class, okay? So because we have online lecture, it's very hard for you to, unless you forget. Okay? And for a few communication, you already know my communication stuff. In fact, you receive a lot of message from me in the WhatsApp group. I keep reminding what's going to happen. So unless you didn't read your WhatsApp message, okay, all right. Yeah. So how are we going to do for tests and exam? We're going to conduct in an online manner. So normally my style will be, let's say for tests, you'll be given 1.5 hours to answer 2 questions. All right. So if the final exam you have 4 questions, you are given 3 hours to answer question. We have 2 sessions. One session you answer question 1 and 2, 1.5 hours. Then you go for a short break, maybe 30 minutes breaks, and then you continue to answer question 3 and question 4. So you will take user about 3 hours in total. Okay, so this is going to work, and we're going to use Teams and as our platform. So after this, make sure you have a stable connection. All right, because we are doing online teaching. So yeah, so you have to find out ways to get a stable connection. Especially when it comes to test and exam, you need to turn on your webcam for along the test or along the final exam. Okay, so I'll give you some time to prepare for the facilities side. So yeah, okay, so just prepare lah for on the your wireless or your internet connection. Right, we need a stable connection for the class and also for the test and final exam. All right, so this will be the schedule on paper. So as you can see here, we will look at the kinematics dimension, then we look at force and acceleration, energy, work. We look at work and energy. We look at impulse, momentum. We look at kinematic problem again on 3D. Before week 7 will be all the 2D dimension. All right, and after your first task, we look at 3-dimensional dimension. And we have a test 2 in week 13, and we try to complete this one before week 14, so that we can have revision in week 14. Okay, we try see how's our class going. Right, I hope in my class we will always have a revision in the last week. Okay, so we see how. If we need more time, then yeah, we do it in 14 for this chapter. One reminder for week 7 or week 8, if you look at your schedule, the university already fixed the time for test 1 and test 2. So get mentally prepared, because by the time of week 7 or week 8, your schedule will going to pack with exam, and even some module ask you to submit assignment. So you'll be very, very busy in week 7. Okay, so mentally prepared and manage your timetable well. If you need to submit assignment in week 7, please plan your time and make sure you clear out all the time-consuming projects that you have before test 1. Okay, so this is the reminder I want you to take care of. All right, make sure your schedule is available for you to make revision for test 1 and also test 2, and you have a final exam in after week 14, right? So this is going to happen for this whole semester. And this will be the book that I will be using. Of course, I will add more textbook. So this one is more in your lesson guide. Later, I'll give you the lesson guide, right? Once we settle down my Teams account, right? So then you will see all the information available to you. So basically, I will be at the moment I show you these 2 textbooks. So if you can go and find it in the library, or you can buy one for your own revision or your tutorial session. So, okay, so in our class, what we're going to do, if you look at the schedule, you have lecture and tutorial separate slot. However, in my class, I will combine lecture and tutorial at the same time. So how will it go is that once I teach you one concept, I will use the concept to apply in the tutorial. So I will do it in the same time. So let's say we learn about F equal to MA, for example, F equal to MA. Then after we learn about the concept, the theory, then I'll give you 1 example or 2 examples, maybe 3 examples of how we apply the equation in the tutorial question. All right. So that is how we're going to do, even though you see your timetable as a tutorial, but I will use that as a lecture. So means I mix the lecture and tutorial in one session. Okay, so that you still fresh when you learn about one theory, and you know how to apply the theory. That is my approach. All right. So I don't wait until we learn all the theory, and then after 2 or 3 days, then only we look at the question. Some universities do that, but in our class, I will do in that way. I teach you one theory, then I'll give you 1 or 2 or 3 questions to look at. Okay, so at least you know, oh, this is how I apply the theory that I learned just now, or maybe 10 minutes ago or 5 minutes ago. All right, so at least you appreciate the knowledge immediately. Okay, so next class after the holiday, we will go into kinematic particles. We will look at all this motion, projectile, how to define them in the Cartesian plane or radial Cartesian plane, rectangular component, and so on. So this will be the textbook I'm using for chapter 1. Okay, so let me stop the recording.